All right, students, welcome back. We are in lesson 19. This is video F. We're going to do sample size. Now, we've done this already for proportions, and so now when we're working with quantitative variables and calculating sample means, we can also run a sample size calculation. Before we collect our data, how much data do we need to have? All right, so here we go, determining sample size when working with means. Before engaging on a statistical study to investigate a population, care should be taken to collect a sample size that will meet our needs. So we need to get enough data to have a useful sample size. A few things to consider. Number one, what margin of error can we live with? Number one, what margin of error can you live with? If your interval is too wide, that'd be a big margin of error, right? Because your interval would be wide. It'll probably be difficult to make useful decisions. On the other hand, if you require a super skinny interval, you're probably going to need more data than you can afford to collect. So it's a balancing act with, what do you want to spend on the project versus what can you live with in terms of the margin of error. And finally, the number two, what confidence level do you require? Number two, what confidence level do you require? Now, of course, that can really be anything, but the two most popular ones in practice, 95% and 99%. If you want to be more confident, 99%, then your interval will need to be wider. Okay, and that's common sense, and we've learned that before. If there are severe consequences, if you create an interval that does not capture the parameter you're estimating, then you better be more confident, right? So, sample size formula. Here's where it comes from. If we look at the confidence interval formula and sort of algebraically manipulate it, then we can solve for n. So, let's see here. Yeah. I start with margin of error. And remember, we're working with a t instead of a z because we're in the chapter for means. And margin of error equals t times s over the square root of n. And so in this lesson, part F, we need to solve for n. I see a square root down there in the bottom. I can square both sides. And if I do that, I'll get margin of error squared would equal, all these pieces and parts get squared here. So t squared, up top, s squared. And I guess now that's just divided by n, because if I square the square root, I'll just get divided by n. And so multiply both sides by n, divide both sides by this margin of error squared, and we will end up with n equals t squared times s squared all over margin of error, quantity squared, right? That's one thing. And since all three pieces are squared, it looks better pulled outside. So n equals whole thing squared. We'll do a t times an s all over, let's see, margin of error, and that whole thing there will get squared. Okay? Now, a couple of problems here. This t number is based on degrees of freedom. Remember, we have to go to StatCrunch and get that critical value t, and it's based on degrees of freedom, which is based on sample size. And we're calculating sample size. So we have a little bit of a problem here. Number two, this value s is the sample standard deviation, and we haven't collected our data yet. So if I haven't collected my data yet, how could I know the value of s? And so in this formula, we have a problem because 2 out of the 3 numbers I think we're going to have a hard time sort of coming up with. All right, so we need to do a little bit of a workaround here. Let me flip the slide, clean the board up. Nothing's ever easy, right? Problems. For one, we won't know the value of s until we collect our data, which we haven't done yet. And number two, also the value of t depends on degrees of freedom, which depends on sample size, which we are in the process of determining. So let's fix the problems. Solution part one. Instead of a t, we just use a critical value z. Okay? So for 90% confidence, remember the critical z-scores, we wrote them down in the proportions chapter when we did confidence intervals. And you can get these from StatCrunch if you pull up the normal calculator and pop 90% in the middle. And so for 90%, the number is 1.645, and that should ring somewhat of a bell because we've used it a few times. For 95%, of course, this is the one everybody knows. Z would be 1.96. For 99%, Z would be 2.576. And if you get a crazy 98% here, let me see how I rounded this. Just did 2.33. Now these are by far the four most common confidence levels, and those two over there are by far the two most common. So if we're calculating sample size, use this number instead of T. Okay? Now, next part. Solution part 2. Come up with an educated guess for the standard deviation. Don't make a wild guess. Don't just pluck a number out of the sky and say 4, right? Come up with an educated guess. Usually there'll be a previous study or a common sense value. So if we were trying to estimate the mean height of 8th graders, say just the male 8th graders, and I said take a guess at what the standard deviation is, good guesses would be 2 inches, 3 inches, 4 inches, somewhere in there. Bad guesses would be 3 feet, right? That doesn't measure the spread of heights when we're looking at 8th grade males. So common sense value or previous study. Sample size calculations are big estimates anyhow. All right, so the formula we'll use when determining sample size is n equals, I'll put brackets, whole thing is squared, and we will use a z, and we will multiply that times the best guess for standard deviation, and then that will get divided by margin of error. Square the whole thing and then round up to the nearest whole number. The answer has to be a whole number, and the reason for sample size only we always round up, because to have that margin of error requirement and that confidence level requirement, we need at least this much data, so we'll round up just to be conservative. Okay, so there's the formula. There's 2 examples at the bottom, and I just would like to do those quickly, and then we'll wrap up lesson 19. There's only 2 lessons to go, so who's excited about that? All right, here we go. First one, say that we'd like to estimate average IQ for Cecil College students. We know in general IQs follow a normal model. In general, the mean's 100. In general, the standard deviation is 15. Here at the college, who knows what the mean is? Could be higher, could be lower, could be 100 exactly. That's why we're running the study. We'd like to be 95% confident, and we'd like to be within 2 points of the true mean. How many students should be sampled? And so we've got a blank slide here. Let's try to remember a few numbers. It said that we want to be within 2 points. So margin of error equals 2, and it's 2 IQ points. So don't turn this into some sort of decimal 0.02 as if it were 2%. We're working in the units of the problem. The units are IQ points, and so this is 2. Got it? We're told what was the confidence percentage. 99% confident. We're told that. So the 99% tells me that the z number that we will plug in is 2.576. And we need an estimate for standard deviation. If IQ scores have a standard deviation of 15 in the general population, I don't see why that's not a good enough guess for Cecil College. So for our standard deviation guess, we'll call it 15. I can't think of a better guess than that. plug it into the formula. It's quite an easy formula. N equals, whole thing is squared, so be careful. Let's see, what goes up here? The z number, right? 2.576. What goes here? The 15. Standard deviation estimate. Down below, margin of error that we require, 2 IQ points. And I can't really do that in my head, but I do have the answers here on the paper. This turns out to be 373.3. We will round that up, and so use n equals 374 students. I'm not sure what it costs to administer a true IQ test, but that's a pretty big sample size. This might get costly, right? Maybe think to yourself, can I relax a few things if I wanted to sort of get that sample size maybe more cost-friendly? Are there a few things I might be willing to give up to get that sample size down? All right, so I guess that's it for this one, right? We'll use n equals 374. There's one more down at the bottom, and that will do it for this one. So, sample size problem. You've got to read this and look, what am I solving for? Is the problem asking me to compute a confidence interval? Sort of has to say that. Is the problem asking me to run a test? It has to say that. What does this one say? It says at the bottom here, how many customers should they attempt to survey? That tells me solve for n, sample size. Walmart managers want to estimate the average receipt amount for their competitor Aldi. So they will attempt to collect data from the customers in the parking lot. Not sure how well this is going to go, but they're going to go for it. They want to get within $3 of the true mean amount. They'll go with 95% confidence. They know at Walmart their own standard deviation for groceries is $32. So they'll just use that value in their calculation. Now, Aldi's a smaller store, Walmart's a gigantic store. You might think to yourself, wouldn't the standard deviation be smaller at Aldi? And it probably is, but think about this. If they use $32 in their calculation and that's too big, it's going to tell Walmart to collect more data. It'll crank up the value of n, so it's probably a good error to make. All right, how many customers should they attempt to survey? Write down a few things here. The margin of error, they'd like to be within, what, $3? So there's that. The standard deviation estimate, they're saying is what? They're saying it was, $32. And the 95% confidence would tell me that the z number is that familiar 1.96. So solve for n. How many customers? N equals. Put the whole thing in brackets. Whole thing gets squared. What goes here? Z 1.96 times standard deviation estimate, $32, and divided by margin of error estimate, $3. I guess the dollar signs would cancel, right? Which makes sense because we should end up with number of people. And so put this in your calculator, square the result, and it turns out you'll get 437.1. 437.1, so Walmart should target n equals 438 customers. Once they collect that data, ask every one of those customers how much did you just spend at Aldi, and they can use that data to run their tests and compute their confidence intervals. Okay, so pretty short video, at least it seemed that way taping it. And so this wraps up lesson 19. We've done confidence intervals for means, now we've done sample size for means, and what's next? Running those hypothesis tests for means. So thanks for watching, and we will see you in class.